basic trigonometric formulas, we need to remember two functions. Sine x plus y equals sine x cosine y plus cosine x sine y. And the second one is cosine x plus y, which is equals cosine x cosine y minus sine x sine y. You need to observe carefully when you are writing sine x plus y, you see the right hand side sine cosine comes together and plus sign is preserved. So we have sine x cosine y plus cosine x sine y. And then if you go to the second formula, cosine x plus y, in this case cosine cosine sine sine all are separated. So you have cosine x cosine y, sine x sine y, and alternate sign. The same way other two formulas you can easily recall, like sine x minus y will give you sine x cosine y minus cosine x sine y. And cosine of x plus y equals, you have cosine x cosine y minus sine x sine y. If I replace y by negative y, we get cosine x minus y. That will be cosine x cosine y plus sine x sine y. Now we will try to find more trigonometric identities from equation 1 and 2. For example, in equation 1, if you replace y by x, you can easily see that it is sine x plus x. So what happens with sine x plus x? So that gives you right hand side sine x cosine x minus, plus cosine x sine x. So this is giving me now double angle formula. So I replace y by x. So I'm getting in the left side sine 2x, and on the right side now you can combine, you get 2 sine x cosine x. If we divide both sides by 2, I get 1/2 sine 2x equals sine x cosine x. For upper level math classes, these formulas are really useful. So you need to remember this. From the second one, if I replace y by x, I'm getting cosine x plus x. That gives me on the right hand side cosine x minus sine x sine x. So this one basically cosine square x minus sine squared x. And now you need to recall other basic trig identity, which is sine squared x plus cosine squared x equals 1. From here, with another transformation, I can say sine squared x is 1 minus cosine squared x, and same way you can say cosine squared x is 1 minus sine squared x. So then if you replace cosine squared by 1 minus sine squared, you get 1 minus this sine squared, and this sine squared will make it 2 sine squared x. Also, if you preserve your cosine squared x and replace sine squared by 1 minus cosine squared x, that gives you 2 cosine squared x minus 1. Alright, so we see now sine x cosine x can be written as 1/2 sine 2x. And cosine 2x is cosine squared x minus sine squared x. And also you have seen 2 cosine squared x minus 1 and 1 minus 2 sine squared x. Alright, now we see 2 cosine squared x minus 1 equals cosine 2x. So then you can say 2 cosine squared x is 1 plus cosine 2x, right? If you add 1 both sides. And then cosine squared x is 1 plus cosine 2x over 2. Same way, we'll see 1 minus 2 sine squared x equals cosine 2x. Now, if you subtract cosine 2x both sides and add 2 sine squared x, so then what do you get? 1 minus cosine 2x equals sine squared x times 2, right? So then 1 minus cosine 2x over 2, that gives me sine squared x. So these are very useful results we'll be using in calculus and in differential equation. All right, so now we summarize what we have got so far. Sine of x plus y equals sine x cosine y plus cosine x sine y. This is your first formula. And then the second one is cosine x plus y equals cosine x cosine y minus sine x sine y. And you just remember three basic identities. Sine squared x plus cosine squared x is 1. And then if you divide this identity both sides by, say, cosine squared x, then you get sine squared over cosine squared is tan squared or tangent squared. And then cosine squared over cosine squared is 1. So this way you get 1 plus tan squared x. And then 1 over cosine squared is secant squared. And the same way, if you divide both sides of first identity by sine squared x, you get 1 plus cotangent squared equals cosecant squared.